here, and Trevor Norman published over 30 years ago that the speed of light's been slowing down. And I have dear friends that were among us here at Calvary that took me to dinner. Hugh Ross and his chairman, Alex Missler, all happened to be old friends of mine, took me to dinner to patiently try to counsel me not to fall into the trap that the speed of light, everybody knows it's a constant, and they try to counsel me not to get carried away with this foolishness that it was, slowing down. And took me to dinner, and I was very polite, but I chose to ignore them. And we published all of that in our journals, as you know. And of course, that has been vindicated and in exciting ways. So the velocity of light thing, and I won't go through that whole story again, but basically, I got ahead of my slides here, so they'll be in the thing for what it's worth. The myths of the present time. Okay, those are past myths. In the present, we still live with the myth of evolution. When we say evolution, we don't mean evolution, we mean biogenesis. But the point is, that term is still taught in school. It's still the bedrock of our culture, even though it's provably false. And an increasing number of scientists have published clearly that it no longer is a viable explanation of our origins. And we're indebted to Michael Denton in 1986, and Philip Johnson, and Michael Behe, they've published books in recent years that have put the evolution thing, turned it upside down. And these aren't Christians, they're just clear thinkers. And interesting, so the evolution thing to anyone that reads and understands, is foolishness, and yet it's still the bedrock of our culture. The velocity of light still being a constant is debated by many, and so forth. Let's take another thing, the nebular hypothesis. This is still taught in college today, okay? Because what is it? A typical quote from Immanuel Kant, I'll quote, "Some 4 billion years ago, the sun had ejected a tail or a filament of material that cooled and collected and thus formed the planets." Or some variation of that is what you will still find in astronomy textbooks, the solar origin of planets. Now, it turns out 21 years before Kant, this idea came from Emanuel Swedenborg, and he's quite a character, a mining engineer with quite a range of interests, and he also claimed to have psychic powers. And he came up with this nebular hypothesis idea from seances with men on Jupiter, Saturn, and places more distant. Does that give you some new confidence in Swedenborg? Don't laugh. There are people that take him very seriously. Some 20 years earlier, he had a chance to meet Edmund Halley, who is of Cambridge. He was famous for his predictions about the comet that bears his name. Well, he went to Immanuel Kant and Pierre Laplace, who was a famous mathematician. He lent his endorsement to Kant's theory that he got from Swedenborg, but he did it without checking the mathematics. He had the math background to puncture this. He didn't bother to do that. So the nebular hypothesis gained widespread respectability despite its mathematical flaws. Subsequent writers have continued to develop variations of the view even though increasing difficulties renders it very doubtful. What am I talking about? We know that the sun contains 99.86% of all the mass in the solar system. Think about that. The sun is virtually most of the mass of what we call the solar system, almost all of it. Yet the sun contains less than 2% of the angular momentum. The 9 planets contain 98% of the angular momentum. What's that got to do with anything? It simply means that the planets couldn't have come out of the sun and cooled. And this was known, by the way, at the time of Laplace a century ago. There's no plausible explanation that would support a solar origin of the planets. You can try to formulate one. It doesn't work that has any mathematical integrity. Now, it gets worse. James Jeans pointed out that the outer planets are far larger than the inner ones. That's very hard to explain. Jupiter is almost 6,000 times as massive as Mercury, almost 3,000 times as massive as Mars. And those are problems if you try to make a model for that to have happened somehow. So this is the difficulty with current theories. There's other enigmas. As we study the planets, we discover they apparently are in pairs. The rapid spin rates among the planets are within 3% by pairs. And as you look at this, the Earth and Mars, Jupiter and Saturn, and Neptune and Uranus are within 3% of each other. Why? Why are they paired in their spin rates? Nobody knows. Earth and Mars have a virtually identical spin axis and the same tilts, 23.5 degrees. Why? Nobody knows. From the angular momentum, pairs of these planets that may have been brought, it appears that they were brought here from somewhere else. I'm speaking just in terms of secular conjecture so far, you follow me? Why does Mars have 93% of its craters in one hemisphere? The craters on Mars, 93% are in one half of the thing, and there's only 7% in the other half. In fact, as they study it, it would appear that 80% of those craters occurred within the same half hour. Why? Nobody knows. But these are unexplored aspects to their origins. This gets to some other conjectures that you've all heard about, the idea of dark matter. The quote that you see in many articles, dark matter makes up about 26% of the universe. Really? The first hint of its existence came in 1933 when the astronomical observations and calculations of gravitational effects revealed that there must be more stuff present in the universe than telescopes could see. That's a widely held belief of many of our top scientists today. Why? I'll show you why in a minute. There's also dark energy. Dark energy makes up approximately 70% of the universe and appears to be associated with the vacuum in space. Well, there isn't a vacuum in space, but that's a whole other thing we'll get into. It is homogeneously distributed throughout the universe, not only in space, but also in time. In other words, the effect is not diluted as the universe expands. Really? These things are non sequiturs, and yet they're widely held among scientists. In fact, you should stand back, and it's humbling to realize that all that we know about matter comes from a 4% sample. There are books that tell you 96% of the mass of the universe is missing. How many have heard that somewhere? That's ridiculous, of course, it turns out, okay? And most of you are familiar that they're chasing some of these things with big dollars. The Large Hadron Collider in CERN in Europe. It spans the border between Switzerland and France near Geneva. It's 300 feet underground. It's the largest machine in the world, a circumference of 17 miles. It's the fastest rate track in the world, trillions of protons traveling at almost the speed of light, guided by 9,300 magnets. We spent a lot of money here. 600 million collisions each second, and we could go on and on about this thing. There's also a project we're going to talk about a little bit called the GEO 600. This is an attempt in Europe to measure, to try to find and measure gravity waves. And the pursuit is the relativistic gravitational fields implies the existence of particles called gravitons. These are particles that have never been seen that they're going to try to find, okay? Massless, uncharged particles moving at the speed of light, but so far undetected. Now, kind of interesting sidelight here, in making this project, they discovered that there's some noise they encountered. And in Europe, the head of Fermilab wrote them a letter suggesting that that noise might be due to the granularity, due to the fact that the universe is a hologram. And that's caused a whole stir. That discovery may be more important than the gravitons they were trying to find. And there are experiments going to be conducted this summer to try to confirm that. David Bohm, a confederate of Einstein, said he was a guy that happens to have, David Bohm's an interesting guy. His background was in plasma physics. He was fascinated with plasmas. We're going to talk about that tonight. But he came to the conjecture that the universe may be a super hologram. That's why this GEO discovery is so exciting, because it reopens that whole discussion. And so the GE 600 is a gravitational wave detector located in Germany and so forth. I won't go into, we have to go into all this stuff. Well, to give you some feeling what the money they're spending, it's designed to detect relative changes in distance, the order of 10 to the minus 21 centimeters, about the size of a single atom compared to the distance from the sun to the earth. That's accuracy. That's what they're struggling with. And so we'll see what happens anyway. I don't want to spend too much time on gravity waves other than they were predicted by Albert Einstein, but never been actually observed. And that's what the GE 600 is chasing.